Imagine whispering an idea into the void, a snowy mountain, but made of chocolate, a futuristic city floating above the ocean, yourself as a cyberpunk hero. And within seconds, the void whispers back with a picture that never existed. Welcome to the world of diffusion models, the engine behind modern AI art, video generation, image editing, and scientific simulations. But how does a machine turn random noise into breathtaking visuals? Today, we're going deep, yet keeping it simple, into one of the most magical innovations in modern AI. Why diffusion models matter. Before diffusion models, AI struggled with image generation. GANs were impressive, but unstable, hard to train, and unpredictable. Then came diffusion models. They didn't just improve image generation, they revolutionized it. Powering tools like Stable Diffusion, Midjourney, Runway Gen 2, and even Apple's new real-time generative systems. These models let you generate art, edit photos, create videos, expand images, remove objects, fill missing details, simulate weather, molecules, proteins. They're not just about art, they're reshaping science, medicine, entertainment, and design. The intuition behind diffusion. Let's explain diffusion using something simple, a photograph. Think of an image as a structure. Diffusion models do two things. First, destroy the image, forward process. They add controlled noise repeatedly, just like sprinkling sand on a drawing until it's no longer recognizable. After enough steps, you get pure noise. Then, rebuild the image, reverse process. This is the magic. The model learns how to remove noise step by step until the original image appears again. Now imagine doing the reverse without ever seeing the original. Just from the noise alone, the model can pull out shapes, textures, patterns, eventually producing a brand new image. This is why diffusion feels like AI sculpting something out of chaos. The technical breakdown. Step 1. Forward diffusion, adding noise. A clean image, add Gaussian noise, repeat. After T steps, the image becomes pure noise. Formula. Step 2. Reverse diffusion, removing noise. The model is trained to predict the noise added at each step. Subtract the predicted noise. Repeat until you get a clean image. When you start with random noise, the model has no structure to follow. So where does the structure come from? From the prompt. But how? Through conditioning. Your text prompt is converted into a numerical representation called an embedding, using a text encoder like CLIP or T5. For example, prompt like, "a cat wearing sunglasses in cyberpunk style," becomes a vector that encodes concepts like cat, sunglasses, cyberpunk, neon, futuristic, lighting style. This vector is fed into the diffusion model at every denoising step. During training, the model sees many examples of noisy image-clean image pairs with their associated captions. Over time, it learns patterns like, when the prompt says cat, the denoised image should have cat-like edges and shapes. When the prompt mentions sunglasses, dark oval shapes should appear around the face region. When the prompt says cyberpunk, neon glow and vibrant colors should emerge. So during inference, each denoising step becomes a small pull toward features that match your prompt. Why this works so well. Stable training, high fidelity, amazing diversity. Works well at scale. Flexible, images, audio, 3D, depth maps, video. This is why companies love it. Practical examples. Turn your sketch into a realistic image. You draw a rough cat. Diffuse it. Model reconstructs the image. Output, realistic cat photo. Expanding an image beyond its frame. Take a portrait cropped tightly. Outpainting lets the model imagine what's outside the frame. AI removing objects. Remove a person from a photo. Diffusion fills the background logically. Grass, shadows, textures. Generate video from text. Modern diffusion models create short videos. A drone flying over neon Tokyo at night. 5-second video. Scientific use. Diffusion models help predict molecular structures, design new proteins, simulate weather patterns, enhance MRI and CT images. The future of diffusion models. What's next? Real-time diffusion. Your phone generating images instantly. 3D and 4D diffusion. Full worlds created using a short text prompt. Video editing like photo editing. Anything you imagine, frame perfect. Personalized diffusion models. Your style, your preferences. AI that feels yours. Hyper-efficient diffusion. Models that run locally, privately, offline. Diffusion models are more than just a trend. They're a new creative medium, a new scientific tool, a new way for humans to express ideas. We're witnessing AI's version of the Renaissance, powered not by paint or pixels, but by noise and imagination. If you're curious about the future of AI, diffusion models are just the beginning.